Every photo you've ever seen of space is lying to you, not on purpose. But look again, galaxies, stars, light everywhere. That's not what's actually out there. The truth? The universe is almost entirely empty. Less than 5% of it is something you could ever touch or see. The rest, dark matter, dark energy. We know it's there because without it, physics breaks. But no one has ever seen it. Not once, and even that tiny 5%, it's not spread out evenly. It's clumped along the edges of bubbles of pure void. Everything you see in the night sky, every star, every galaxy is the exception, not the rule. So how empty is empty? Not in numbers that sound impressive way, in a way you can actually feel. Let's start small. Pluto, 6 billion kilometers from the sun. Light, the fastest thing in existence, takes over 5 hours to get there. New Horizons, the fastest spacecraft ever built by humans, took 9 years to reach it. 9 years to get somewhere that's still technically our backyard. And when it arrived, it had 30 minutes to do its job before flying past forever. Here's the part most people don't know. Pluto isn't even the edge. The Oort Cloud, the actual boundary of our solar system, stretches up to a full light year out. We've never seen it directly. We only know it's there because of how comets behave when they swing in from nowhere. Voyager 1, launched in 1977, the most distant man-made object in existence. Today, it's 23 billion kilometers away. At that speed, it would take another 30,000 years just to clear the Oort Cloud. We've explored none of it. Literally none. Now we leave everything familiar behind. Proxima Centauri, the closest star to us, 4.2 light years away. Here's what that actually means. Light travels 9.5 trillion kilometers in a year. Proxima is 4.2 of those away. At New Horizons speed? 70,000 years to get there. The Roman Empire was 2,000 years ago. We wouldn't arrive with anything we have today, not our technology, not our species as we know it. Quick twist, Proxima has a planet. Proxima b sitting right in the habitable zone, the sweet spot where liquid water could exist. But Proxima is a red dwarf. It throws out radiation flares violent enough to sterilize anything nearby. Life there? Questionable at best. Quick question, how many stars do you think are in our galaxy? 200 to 400 billion sounds packed, right? It's not. The average gap between stars near us is several light years. Which means, even when galaxies collide, and Andromeda will collide with us in 4 billion years, the stars almost never touch. Two galaxies colliding is really just two clouds of emptiness passing through each other. The Milky Way isn't even shaped how you'd picture it. Spiral arms, a central bar, a bulge, a halo of ancient stars wrapping the whole thing. And dead center, a black hole 4 million times the mass of our sun. We're not at the center. We're not at the edge either. We're in the middle of nowhere, inside a galaxy that is itself mostly nowhere. 100,000 light years across. Some estimates say 200,000 at light speed, the fastest anything can physically travel. Crossing it once would take 100,000 years, and that speed limit isn't a technology. Problem we'll eventually solve. It's physics. Push anything with mass toward light speed, and the energy required climbs toward infinite. There is no engine, no fuel, no future technology that gets around that. Andromeda, our nearest big galactic neighbor. 2.5 million light years out. Go outside on a clear night and look for it. If you find it, you're not looking at Andromeda as it is. You're looking at light that left it 2.5 million years ago, before your ancestors used tools. Zoom out further, the local group, about 50 galaxies in a 10 million light year radius. Past that, nothing, until the Virgo cluster, 65 million light years away, and the space between galaxies. Forget rare. It's roughly 1 atom per cubic meter. No dust, no gas, no magnetic fields. Just vacuum so complete it's hard to picture. Light passing through it doesn't hit a single thing. It just keeps going, forever. Zoom out even further, and the chaos becomes a pattern. Galaxies cluster into superclusters. Superclusters link into filaments, threads of matter millions of light years long, forming a structure across the entire universe. We live in one called Laniakea, discovered in 2014, barely over a decade ago, when scientists noticed thousands of galaxies all drifting toward the same invisible point. 520 million light years across, 100,000 galaxies. Between these threads, voids. The Bode's void, not found in 1981, is 330 million light years wide and contains a few dozen galaxies where there should be thousands. Even the voids aren't fully empty. The galaxies that do exist inside them evolve differently. Fewer neighbors, fewer collisions, slower growth. Isolation literally changes how a galaxy develops. And the biggest known structure? The Hercules Corona Borealis Great Wall, 10 billion light years long. So big, some scientists aren't sure it should even be classified as one structure. On scales this large, the universe is supposed to look uniform. It doesn't, and we don't fully know why. Here's the part that breaks people's brains a little. The James Webb Telescope has captured galaxies over 13 billion light years away. That means we're seeing them as they were less than a billion years after the Big Bang. The universe is 13.8 billion years old. Those galaxies? They've changed completely by now. Some don't even exist anymore in the form we're seeing. We never see the universe as it is. We only ever see how it was. Push that limit far enough, and you stop seeing galaxies entirely. You hit the cosmic microwave background, leftover radiation from when the universe was too hot and dense for light to even move. That's the wall, not darkness beyond it. A physical wall from the past itself. Space itself is expanding. Not into anything, and space is the thing growing. Some galaxies are moving away from us faster than light travels. That doesn't break physics. They're not moving through space. The space between us is what's stretching. Light leaving those galaxies today will never reach us, ever. In a few trillion years, every galaxy outside our local group will vanish past the cosmic horizon. Not destroyed, just gone from view forever. Imagine a civilization existing then. They'd look up and see nothing but their own galaxy. No evidence anything else ever existed. They'd ask the exact questions we're asking right now, and they'd never get an answer. We sit on a planet around one star in a galaxy of billions. In a universe of trillions of galaxies. And despite all of that, or maybe because of it, the universe isn't defined by how much is in it. It's defined by how much isn't. Here's what stays with me. Right now, somewhere past our cosmic horizon, a civilization could be living out its entire existence. Rising, building, asking the same questions we are, and we will never see them. They will never see us. Not because they're too far in space, but because the space between us is growing faster than light can cross it. We're not separated by distance. We're separated by time itself running out before the light arrives. So here's what I actually want to know. If a civilization can exist and we'd never have any way of detecting it, not now. Not ever. Does that change how you think about whether we're alone? Tell me below. I actually want to know what you think is hiding in those voids.